All right, in this video, we're going to finish the Module 9 study guide. We have question 8. So we need to factor 3x squared minus 20x minus 32. So my a is equal to 3, my b is equal to negative 20, my c is equal to negative 32. So remember, when we're factoring, we have to do our a times our c. So these are all the graphic organizers we use. So this is what I recommend you use for the test. So first, we're going to fill in our area model with the 3x squared and the negative 32. Then we have to figure out what's going to go in the other two rectangles of our area model. So what is a times c? Well, that's 3x squared minus 32. So when we multiply that together, 3 times negative 32, we get a negative 96. And our b term is negative 20. So the numbers that multiply together to give me negative 96 are 1 and negative 96, 2 and negative 48, 3 and negative 32, 4 and negative 24. Of those, the ones that add together to give me negative 20 are 4 and negative 24. So that will complete my X puzzle, or that's what I can use to fill in my area model. Now I have to find my greatest common factor of the columns. So 3x squared and a positive 4x, I'm going to factor out an x. Then I have negative 24x and a negative 32, or I can look here at this top row, 3x squared minus 24x, and I'm going to factor out a 3x. Okay, well, 3x times negative 8 will give me the negative 24, and negative 8 times what number is going to give me negative 32? Well, that's a positive 4. So to write my factors, I'm going to do 3x plus 4 and x minus 8. And that is my factored form of 3x squared minus 20x minus 32. All right, question 9. We have to factor by grouping. Your clue is that we have 4 terms. So remember, when we have 4 terms, we're going to factor by grouping. So we have to split this polynomial into 2. So looking at this first half that I highlighted in green, what is the greatest common factor of the first 2 terms? So we're going to find the factors of 4n to the power of 3 and negative 12n squared. So the factors of 4 are 1 and 4, 2 and 2. The factors of negative 12 are 1 and 12, or 2 and 6, or 3 and 4. So my greatest common factor is 4. Then if I'm looking at n to the power of 3 and n to the power of 2, n to the power of 2 is my smallest variable with the exponent. It's my smallest exponent, so my GCF is 4n squared. So I'm going to factor out the 4n squared from those first 2 terms. When I divide those first 2 terms by 4n squared, I'm left with n minus 3. Now I'm going to find the GCF of the 3n minus 9. Okay, so the factors of 3n are 1 and 3. The factors of 9 are 1 and 9, or 3 and 3. My greatest common factor would then be 3. And I cannot factor out a variable here because the negative 9 does not have a variable. So my GCF is 3. I'm going to factor out that GCF from the second 2 terms. When I do that, I get a positive 3 multiplied by n minus 3. Now I can factor out the n minus 3 because they are the exact same parentheses. And I'm left with 4n squared plus 3 as the remainders in my second parentheses. All right, last question, second to last question. Question number 10, the polynomials p of x and g of x. So we need to find the product. Find the product means we are multiplying the trinomial p of x times the trinomial q of x. So we're going to set up our area model, and we're going to multiply all of those terms together and fill in each box. So x squared times x to the power of 3, that's like having 1 times 1, and x to the power of 2 times x to the power of 3. We add those exponents, and we get 1x to the power of 5. X squared times negative 3x, so that's 1 times negative 3, and x squared times x to the power of 1. Remember, add this 2 plus the 1, so I get negative 3x to the power of 3. Then I have 1 times 2, or x squared times a positive 2, and I get 2x squared. positive 3x multiplied by x to the power of 3. And I have 3 times 1, which is going to give me 3. And x to the power of 1 times x to the power of 3. And I get x to the power of 4. So my final term there is a positive 3x to the power of 4. Positive 3x times a negative 3x. And I'm going to get a negative 9x squared. Positive 3x times a positive 2. And I will have a positive 6x. Then here we go to the last row. Positive 3 times x to the power of 3. And I'm going to get a positive 3x to the power of 3. Positive 3 times a negative 3x. And I get a negative 9x. And positive 3 times a positive 2 gives me a positive 6. Now I have to look to see if I have any like terms in my table or in my area model. I do not have another x to the power of 5, so I'm going to write that. I have 3x to the power of 4 minus 3x to the power of 3 plus 3x to the power of 3 plus 2x to the power of 2 minus 9x to the power of 2. Then I have plus 6x minus 9x plus 6. And now I have to combine my like terms or simplify my polynomial. So I have negative 3x to the power of 3 plus 3x to the power of 3. That's going to become 0. There is no more x to the power of 3's remaining. So don't put 0x to the power of 3 or don't put just x to the power of 3 because there's 0 of them left. Plus 2x squared minus 9x squared gives me a negative 7x squared. If you're not good with negative numbers, use a calculator. Plus 6x minus 9x, and I'm going to get a negative 3x. I have no other terms to combine with the terms that are not highlighted, so I can just write those. And my final answer is x to the power of 5 plus 3x to the power of 4 minus 7x squared minus 3x plus 6. Notice I do not have an x to the power of 3 term. It was canceled out. All right, one last question, question 11. Simplify and write in standard form. So we have to distribute this negative 1/3 x into the parentheses. Use a calculator if you don't know how to multiply fractions. So negative 1/3 times a negative 5/2 is going to be a positive 5/6. X times x to the power of 2 becomes x to the power of 3. Negative 1/3 x multiplied by a positive x is going to be negative 1/3 x squared. And negative 1/3 x multiplied by a negative 3 will become a positive 1x. That's it.